Hello and welcome back from your spring break. On this little video, I want to kind of remind us of some things we've done in the past and kind of where we're headed this week. So what I have here on my screen is the conditions for inference. You might recall that we worked a lot with percentages and proportions over the last couple weeks. And here I've kind of written down the three different conditions for inference when we worked with proportions, things like p hat or p1 and p2. And then the week before we went on break, we started looking at averages or means, sample means. And so just to remind you of what the different conditions were, we want to make sure the sample is randomly selected from the population. We want to make sure the sample size is sufficient. And the way we did that is we looked at small samples where there were less than 15 items in the sample. The sample must be selected from a normal population, or the graph, and we'd make a box plot for this, a modified box plot, its graph must have no outliers and little, if any, skewness. And then, of course, the sample is not too large. So it may have crossed your mind, maybe not, that, well, what if n was bigger than 15? What if I had a sample of, say, 15 or 20 or maybe 30 items? Would this condition here still apply, or is there a different condition? So again, the idea is, well, what if the sample size is 15 or more? What do we do in that particular case? So to kind of help you understand what we do, I'm going to give you a little bit of background here. So here I have an applet that allows me to make a population, and from that population I can randomly grab a sample, and I could do that thousands of times and create a sampling distribution. So let me illustrate with a few examples. So I'm going to start off with a kind of a normal population. The mean is 50 and the deviation is 10. And what happens when I sample from that? So I'm going to go ahead and take a small sample, let's say 10 items. Okay, so 10 items. Let me go ahead and reset everything. Okay, so I've got my population, and I'm going to take a sample of 10 items. So I'll just illustrate. I'll take one sample of 10 items. So this randomly grabs 10 items, and here's a display of the 10 items that were grabbed. And then the average, okay, of those values, okay, let me go ahead and plot that right here. Let's see if I can turn that on. Let's see, I want to show the sample mean. So the sample average is right about here in blue. And so then let me go ahead and draw another sample of 10 items. So here's another sample of 10 items, and this time here's the sample average in blue. And then I'll draw a third sample, and here's the third sample. Here's the average of the third sample, and notice how there are little blue marks here where the sample's averages land. And if I took another sample, there's an example. If I took another sample, there's an example. And the question is, well, what are all these sample averages going to look like in the long run? So I can jump ahead and say, well, let's take 1,000 samples. 1,000 samples. I'm going to draw 1,000 samples. And okay, so here's the 1,000th sample. And then here's a graph of the 1,000 or so different averages that I've got. So I'll take another 1,000 samples. I'll take another 1,000 samples. Now, if I want to speed this up a bit, let me go ahead and take 10,000 samples. 10,000 samples. And you'll notice that the sampling distribution looks pretty normal. We call this actually a t-distribution. In fact, I can turn on a normal approximation, and you can see that the graph in blue is very, very close to a normal curve. We call it a t-distribution with, in this case, 9 degrees of freedom. So let me go ahead and shut that back off. So small samples, okay, as long as we have a fairly normal looking population, no problem. But let's say we don't have a normal population. So let me go ahead and reset everything. And now I'm going to change the population just to one that's skewed. And this is what usually happens. And I'm not going to go with extreme skewness, but let's kind of start with, okay, that's symmetric, that's normal. So let me give it a little bit of right skewness. So here I've got a population that skews a little bit to the right. And I'm going to again take a sample of 10 items. Okay? And I'm wondering, what's the sampling distribution going to look like? So let me take 10,000 samples. I'm going to go ahead and draw those 10,000 samples. And here's what the sampling distribution looks like after 10,000 samples. And if you look at it, you'll notice it's a little bit skewed to the right. Okay, a little bit skewed to the right. Let me put in the normal distribution to kind of compare. And you see how it's a little, it seems like it's a little shifted over to the left. We've got a little bit of a right tail, in other words. And so a small sample, like 10 items, if it's coming from a skewed population, we're not going to get that kind of nice normal or t distribution. We have to raise the sample up. So I'm going to go ahead and reset this. And I'm going to go ahead and raise the sample up to, say, 20 items. 20 items. Okay, let me go ahead and reset, clear all that out. So once again, I'm going to take 10,000 samples, and I'm going to draw the samples. And there's the sampling distribution. You're going, okay, maybe there's a little bit of right skewness, hard to tell. So let me go ahead and put a normal approximation in there. And you're going, okay, it fits a little better than the one before. So a sample size of 20 is a little better than a sample size of 10. Let me go ahead and raise it up a little more. Clear that out. So let's say we take it up to, say, 30. 8, 9, 30. So I'm going to sample 30 things. And again, let me just clear everything out. I'm going to take 10,000 samples from this population. Let's draw 10,000 samples. In fact, let's go ahead and draw another 10,000. So now we got 20,000 samples, 20,000 sample averages. And you're looking at it going, okay, that's looking a little more symmetric. I don't quite notice the skewness. Let me turn on the normal curve, and you're going, oh, that's a pretty good fit. And you'll find that samples of right around size 30 do a pretty good job in this case of where you've got slight skewness. You just raise the sample size. So let's take one more example. Let's put a little more skewness into our population. Let's go with we call a very right skew. Notice how the tail is getting a lot more to the right. And again, I'll start with a small sample size of, say, 10 items. Okay, so I'm going to go ahead and reset everything. I'm going to take 10,000 samples of size 10 from this population. And so we'll draw 10,000 samples, and we'll draw another 10,000. Let's give us 20. And you can see the skewness here. And so even more pronounced than it was the last time. And we'll kind of put the normal distribution in here. And you can kind of really see the gaps and how the blue graph is kind of shifted a little bit to the left. There's a little more of a tail to the right here. So a sample of a size 10 is probably too small of a sample when you have a population that's, skewed quite a bit to the right. So let's take up to sample size of 20. So there's a sample size of 20. Let me reset. Okay, I'm going to draw my 10,000 samples of size 20. And let me take another 10,000 samples. It's going to be 20,000 samples. And there might be the slight bit of little bit of right skewness here. And we'll kind of put the normal curve in just for comparison. Okay, it's actually not too bad right there around 20. Maybe, maybe a little bit of a tail right there. And so then let's go ahead and take it up to 30. And so sample size of 30. Let me clear everything out. Let's take 10,000 samples of size 30 from this population. And we have that. We'll take another 10,000 samples. So now we've got 20,000 samples, and you're going, okay, well, maybe a little bit of skewness. Let's put the the normal approximate. Okay, again, a pretty good fit. So what we're finding out, okay, is the more skew the population, you want to raise the sample size. In other words, a sample of, say, 10 or 12 or 13 items probably won't be sufficient in this case. We're going to need to take a bigger sample size. And so when you come to class next time, we're going to look at that like, okay, well, how much bigger of a sample do we need to take? How do we know when we're dealing with a population that is skewed? And so we'll kind of take the ideas from before, let's see right here, this n less than 15, and we're going to add a condition that talks about, well, if n's higher than 15, what can we look for in order to do statistical inference? So that'll be next time in class. So thanks much for watching.